Okay, good morning, everyone. Welcome to the second session in the CICS track at this year's GSE UK virtual conference. This is session 4B, Ansible and zOS Cloud Broker in Action with CICS TS. We have two presenters, Drew Hughes and Andrew Tweedle. I'll pass over to one of them. Take it away, Andrew.
Yep. Hi, everyone. I'm Drew Hughes, or Andrew Hughes. It's a longer one, but try and avoid some confusion as you got the Andrew double act this morning. Welcome to this talk on Ansible and zOS Cloud Broker in Action with CICS. We're going to run through, let's actually get to the agenda. We've got a couple of demos for you today. We're going to run through an introduction to Ansible, Ansible and zOS, and talk to you a bit about the CICS collections that we both work on as part of the IBM CICS modernization team. So we're actually going to launch straight away into a demo. So let's hope this all works. So here I've got a local VS Code open here on my Mac, and this is showing a YAML document. And this YAML document is something called an Ansible playbook. So for those of you who aren't too familiar, this is the configuration file that you would normally supply to a technology called Ansible. And this would then run from a control node, which in this case is my local Mac machine. Could be any type of control node, but it's going to run an action on a remote zOS machine. So I'm going to walk you through what this kind of is as we run this as well. I'm just going to change that because I don't need that. So this here is something called a playbook. A playbook consists of a number of tasks. In this one, we only have one task. This task is called create a global catalog dataset. And as you might imagine, based on that name, we're going to be using this to create a new global catalog dataset on a zOS instance. Now, we run, okay, I'll go for a couple more of these parameters. So the task name is called create a global catalog. The actual module that we're running is this global catalog module. This is provided from the CICS collection that me and Andrew both work on. We have a couple of parameters, so input fields to this module, one being a state, describing that this is the target initial state that we are trying to achieve after running this task. We also have a region datasets field here, which is the dataset path that we're going to create this dataset under. And we also have a CICS datasets field specifying our SDFH load dataset on our zOS machine. But we're going to run this with something called an Ansible playbook command. I want to find it, which is the CLI for Ansible on just running playbooks. So if you have a quick look at this command, we're running this from the same local directory as where this playbook is. So that's what I'm doing, /playbook. Also specifying something called an inventory with a -i, just to show you what that inventory looks like quickly. This is the way we're specifying our zOS hosts. So for this is an LPAR that we have here in Hersley. This is my username on that LPAR, and a couple of options about a Python interpreter on that LPAR under zOS Unix and some SSH basic options, but none of that's particularly configurable, so it's fine. So yeah, I'm going to go ahead and kick this off. And what you see is Ansible will process this playbook and we'll go task by task. In this case, it's only one task, and execute them against our managed node. So this takes a couple of seconds just to go along, create the dataset, and what a global catalog dataset is. In this case, it's a vSAM dataset. So we're going to run the define cluster command. Then we're also going to run DFH RMUTL, which is the recovery manager. Oh, it's the global catalog program within SDFH load. So, yeah, just going to run that for a second, and then there we go. So we get this nice little changed field against our LPAR name, which indicates that an action has happened on our LPAR. So switch over to a terminal quickly. Let me pull this down. So in ISPF, let's go have a look. And yeah, I've got a new global catalog vSAM dataset under qa.regions.demo.dfhgcd. What we can also do is simply change this state field to absent. rerun that playbook. And we should go along and run that against the exact same path, exact same data set. But in this case, instead of trying to achieve a state of initial, so creating an initial global catalog, we're going to try and achieve the state of absent. So we're going to delete it. So let's go back to ISPF, F3 out, have another look, and no data set's found. So it's now got rid of it. It's a nice, simple example to kick us off with what a playbook is, what a module is. I've run this from my local Mac and I've made a change on a remote zOS machine. We're going to quickly dive into something a touch more complicated. This is another playbook I have. I'm actually just going to kick this off before I explain what's going on here, because this one takes about 1.5 minutes to run. So I'm going to run this with playbook command. We have these couple of vars prompts at the top. One's asking me for an Apple ID. So I'm just going to enter 1, PZ1, and give it a port. Let's go to 7.01, and we'll kick that off. But so as you might have guessed, if it's asking me for an Apple ID and the port this time, I'm actually going to create a data set for every single type of required data set for a CICS region. And then I'm going to create some JCL to start the CICS region and submit it. So if we go through these modules quickly, you'll see there's modules for auxiliary temp, trace, transaction dump, CSD, global catalog, LRQ, LCD, intrapartition. And then we also have this nice new start module at the bottom as well. What you might notice, unlike this previous playbook where we had the state, the region datasets, and the CICS datasets all under the nice single module, we've now moved this up into something called the module defaults group, which means we can put it all top level, and this will apply to every single module below. Oh, that's not good. All right. Okay. Why is that not worked? Interesting. Right. I'm going to rerun this. Create a CSD scripts. Wouldn't be a real demo if it worked first time, would it? Okay, 2ZP1, 27.1. Okay, so we have all these modules that go through, create the CICS datasets for us. We also have a start one. I'll talk quickly about the CSD module because we have this new capability that we released in the beta about a month ago that allows us to run any CSD UP script against a existing CSD. So I have a nice little script here that's doing some very basic, chucking my port into a new TCP IP service and add in DFH term C. So I get so I also install the default terminals. Then we go on to the start CICS module. I've got some sys overrides here that will to apply to my region. I've got an extra top library to specify some CPSM libraries. And that's about it. Hopefully when this runs through, we'll actually see some useful output. Hopefully it works. So yeah. Okay, this isn't looking like it's going to play ball today. Right. Anyway, what this would do is provision us a full new region that we could then go have a look at and log on to from CICS. I might run this again later in the demo, Andrew, but I'll pass over to you for now and you can explain a bit more about Ansible.
Yeah, no worries at all. Like you said, it wouldn't be a demo if it worked first time. Right, can you see my slides? Awesome. Cool. So I'm going to talk to you a little bit more about what Ansible is and what it does, how it does it, now that Drew has showed it in action. So what is Ansible? It's an industry standard automation tool. So it's used for automating repeated tasks, either manually or on a schedule, things like that. It promotes configuration as code, which we all know is a great thing. It allows your configuration to be maintained in source control like Git. It allows changes to be sort of shareable. Multiple people can contribute at the same time, but changes can also be reverted if necessary. And it's a single source of truth for your automation. So you don't have two different versions living on two different people's machines at the same time. It's a single source of truth. I put their tagline on screen there. It turns tough tasks into repeatable playbooks, which sums up what Ansible does quite nicely. But it also normalizes tooling across platforms. So Ansible is not just a zOS thing. It's very much cross-platform. I'm going to talk about the requirements a little bit later. But essentially, if your device has an SSH connection, it can be automated with Ansible. So obviously, Drew demoed against the mainframe, but it could be databases, it could be virtual machines, could even be certain network switches. So you could automate your networking with SSH if you really wanted to using Ansible, which I think is quite cool. So a couple of key terms that I'm going to use, starting off with a managed node. So this could be one system, this could be multiple systems, but it is the remote host that you're targeting with your automation. In the demo, it was our LPAR here in Hursley, but it's whatever you're targeting with your automation. You've then got the control node. So that's where the Ansible is being run. So it's what's controlling the automation. In that demo, it was Drew's laptop. But again, that could be your machine. It could be a virtual machine elsewhere. It's just whatever's running the automation. You've got a playbook. So that is a YAML file that describes your set of instructions. So it shows what tasks you need to perform, where you're performing them against. One of those tasks is one individual step in that set of instructions. And that task is comprised of a module and its parameters, module being the bit of functionality that you're going to perform. So the structure of your infrastructure, well, that's a sentence, isn't it? The structure is you have one control node, and then you can have one or multiple managed nodes. I've got an example, so there are databases, back end, front end, but they can be anything. As I said, it's powered by SSH by default. Although you're not restricted to SSH, you can connect via other protocols, but all of the demos and things we're doing today are via SSH. Next, we have the concept of inventories. So this is how we tell Ansible where our systems are and how we're going to connect to them. So it's a flexible way of describing your environment. They're YAML files as well. They can be text files, but we tend to use YAML files. And they specify your connection details like your host, your port, your credentials, SSH keys. And you can also provide a name for each of your managed nodes here. You can provide variables that are used at runtime, either scoped to just one managed node or scoped to your whole inventory or anywhere in between. And you can also group nodes together. So if you want to run the same bit of automation against a group of nodes, you put them in a group and you reference that group when you're running your automation. The next bit is playbooks. So you've already seen playbooks in action today, but these are, as Drew said, a list of tasks that you're going to perform. This is a very simple example of a playbook. There is only one task, but there's a lot of parameters that we've had to provide. So right at the top, we give the playbook a name and we say what hosts we want to target. That could be a name of one host. It could be a group name. Instead, we've used the keyword all, which means everything in the inventory. Let's run our automation against that. Then we have the task itself, which also has a name. It's really important to give your playbooks and tasks good names because when you're looking through the logs and the output, it gives you a step-by-step sort of what's happened when, if each task was successful, things like that. So giving them good names makes debugging a lot easier. And then we've also provided some environment variables to that task as well. And then finally, we have the module and its parameters. So the module is the bit of functionality, what bit of code we want to run, and then the parameters tailor that to what you want to do. So here we're running the IDCAMS program, and we're passing in a listcat command to inquire about a data set, and we're specifying that we want the return type to be text. So you can imagine this kind of task will be used to get some information about a data set. Does it exist? What type of data set is it? Things like that. So collections, what are collections? These are extensions to Ansible's core functionality. So Ansible comes built in with lots of functionality for things like editing files, submitting HTTP requests, a long list. But collections allow you to extend that and add your own functionality in, which is what we've done for the zOS collections. So it's a distributed format. It can contain playbooks, modules, plugins, roles, and it's Ansible's way of packaging up that functionality so it can be shared. And there, as I said, there are a variety of zOS-based collections available, which we're going to look at in a second. But how do you go about sharing those collections and installing them into your environment? That is with Automation Hub or Ansible Automation Hub and Ansible Galaxy. So Ansible Galaxy is a public repository of open source roles, collections, and playbooks. Anybody can upload. Java has Maven Central, Python has pip, Node has Node Package Manager or NPM, Ansible has Ansible Galaxy. It's the way of distributing extensions. Automation Hub is the enterprise marketplace of content for Ansible Automation Platform users. So it's included with the AAP subscription. There is a public repository of Ansible certified content. So that's the difference there. You get certified content by Red Hat. And you can also have the option of having a private on-premise repository to share that content just amongst your organization as well, rather than making it public. In terms of running Ansible, so interacting with it, Ansible is a Python package, which means it's installed with pip. And when you install Ansible with pip, you get multiple CLI tools to use. I put a few on screen, so these are the most, well, the ones I use most at least. So Ansible Galaxy, that's used to find and install your collections or extensions into your local environment. You can also use it to publish content as well to Ansible Galaxy. Ansible Inventory is a useful tool to display your inventories as Ansible sees them. So there's one thing thinking that your inventory is configured correctly and you're providing it to Ansible correctly, but it's another thing Ansible seeing that inventory as expected. So this is a good way of troubleshooting that. And finally, Ansible Playbook, the one we use most, which is for running your playbooks. So there's an example of that in the bottom right. For running a playbook, we're providing things like your inventory path, where you're specifying where your managed nodes. You can provide runtime environment variables inline as well. So I'm setting an environment variable there, and then you specify the playbook that you're going to run. And finally, the Ansible Automation Platform, or AAP. I mentioned it a little bit earlier. So this is a wrapper to most things I've just talked about. So you can run your playbooks with a CLI in a terminal interface, but AAP is an alternative to that. It's another method for triggering your automation. It offers a graphical user interface for a lot of the ecosystem. So inventory management you can do with a user interface, configuring your playbooks, managing environment variables, setting up scheduling to run automation once a day, once a week, once a month, whatever. Ansible Automation Platform, it can also pull straight from source control. So if you've got your automation in a source control system like Git, it can pull those in directly from there. It adds role-based access. So it manages who can run what playbooks for you. And it's sort of a cleaner, non-terminal based approach to running Ansible playbooks. So now that we all know everything there possibly is to know about Ansible, how do we go about using it on Z? So there are 3 prerequisites to running Ansible on zOS. I've talked about SSH as a requirement already. Although you can technically use other protocols, everything we're going to be doing is with SSH. So you need an SSH connection. Ansible being a Python tool, you need Python installed on your managed node. So Python on zOS. The reason for that is Ansible when you run a playbook, it actually packages up some Python code, ships it over to your managed node, runs that Python, and then returns the output back to your control node. So that's why you need Python. And thirdly, you need IBM Z Open Automation Utilities, or ZOAU for short. If you want a more in-depth look into ZOAU, how it works, what it does, how you can use it, Drew and I are actually doing a session tomorrow if you're interested. But essentially, it's a set of USS utilities for interacting with MBS resources. I'm not going to go into everything it can do, but things like managing data sets, so reading them, writing to them, deleting them, updating them, jobs, looking at outputs, things like that. But it is extensive. It also provides a set of Python APIs, which we use for the CICS collection to do a lot of the heavy lifting. So that's what you need to get set up on zOS. There is also this concept of certified content for IBM Z. So there are multiple certified collections for zOS. These are collections that are built, supported, and maintained by Red Hat and IBM. They include collections for sort of core utilities, which is the zOS core collection, and a CICS collection, which Drew showed and we're going to talk about in a second. There are also certified collections for IMS, zOSMF, and a couple of others there as well. So what are these certified content collections? So this is the IBM zOS core collection. It's a sort of a general purpose collection for common zOS tasks. On the right-hand side are all of the different modules that you can import and use. As you can see, it's a long list. I'm not going to go through every single one, but things like manipulating datasets and USS files, managing jobs, executing TSO commands, things like that. You can do with this, but you can also orchestrate your existing automation. So a lot of people already have things in place, JCL or Rex, that they submit to do a lot of their automated tasks for them. You could wrap that submission in JCL as a first step, and you can sort of leverage it in as much or as little as you'd like, which is nice. We then have the CICS collection, which is a more specific but still general purpose CICS functionality collection. So this is split into two halves at the moment. Drew was showing the beta release, which contains the region provisioning modules. So that's a module for each required CICS dataset, and then plus a couple of modules to start and stop your region, things like that. And then the other half is fully released, which is the CMCI modules, which are used to get, update, and delete CICS resources via the CMCI API. So it's a way of driving the CMCI HTTP API. That's a lot of acronyms, using Ansible. So again, it is open source, and you can get both the fully released collection and then the betas as well on Ansible Galaxy. And I believe it's my turn to try a demo. So I'm going to demo the CMCI modules of the CICS collection. And this is a playbook that's going to do some data retrieval and formatting it nicely using some built-in Ansible tasks. So first things first, we're saying host localhost. There is a reason for that. So the CMCI modules, because CMCI is already a public-facing API, we don't need to SSH into the system to get the information. We can actually run HTTP requests on the control node to get the information. So in this case, the managed node and the control node are both my laptop. And you do that by specifying hosts as localhosts. We then have two examples of providing information to the playbook. So you can prompt for variables when you run the playbook here by putting, fast prompt. You can set defaults for these, which I'm going to use for my connection information, but you can prompt for information. And the other way is hard coding variables down here. So I have an attributes variable, which is a list of strings. And these are the attributes of the CICS regions that we're going to inquire about. So we're going to use this attributes variable further down. We then get the tasks. So the first task is going to be installing the required dependencies for our CICS module using the built-in Ansible pip module. We provide it the names of the libraries that we want to install. The next task is going to be part of the IBM zOS CICS collection. So IBM zOS CICS using the CMCI get module. Here we provide our connection information, so our host, our port, our credentials, and then the context and scheme. And then we also provide the CICS resource type that we want to inquire about. In this case, we're going to get all of our CICS regions back, and we're going to put the returned information into this result variable. So that's what that means. When we have that result variable, we can then use Ansible's built-in templating module. We're going to pass it a csv.j2 file, which we'll look at in a second. And what we're saying is we want to use that template to create this report.csv. So you can imagine in an auditing scenario where regularly you have to check certain statistics about your regions or see their uptime, things like that. You can use this to automate creating CSVs. So that template looks something like this. I can appreciate this is actually a lot to look at, but essentially what we're doing is we're looping through each of the records we got back from CMCI, so result.records, and then we're saying grab each of our attributes that we provided in the list at the top and put those in a CSV format, so comma separated here, and we get a report back. So if I run that playbook, I'm saying Ansible playbook, we're going to provide it our inventory, which looks something like this, very similar to Drew's. I'm using my user ID. I'm then passing in a variables file. I'm not sure if this is, this is needed for ZOAU. So we're providing paths to our ZOAU installation, our Python path, things like that, as well as some environment variables. And then we give it a path to the playbook. And if we run it, it's going to prompt for our variables. So our host name, our port, our scheme, HTTP in this case, our CPSM context, username and password we don't need. So I can click through and we get some green text with an OK is 3. So all of our tasks passed, and we get this CSV output. So in our list, we've asked for Apple ID, job ID, consoles, code status, start time, and release. And that's what we get for each of our 7 regions. So it's quite a simple example, but I hope it shows how you can use these CMCI modules to sort of inquire information and do some auditing or reporting. I believe that's all I was going to show. So over to Drew.
Yeah, when I can find the buttons, yeah.
Yeah, I'm also not used to Zoom.
Sorry, got an Explorer open. Let's move that. Okay. Right. So I did work out what was wrong with that demo. So I will briefly just go back to that provision in demo, just to show you a little bit more about some of these more new modules. Hopefully this works this time. Is it 1, 2, 7, so yeah, what I messed up was we were using this fancy way of entering vars prompts here, and we were feeding these into the CSD UP script, and basically I called it the wrong variable name. Oh well. So yeah, we do have these new provisioning modules. We have this new capability here, which, as Andrew said, was in the beta. This is driving the start CICS module. The only reason I wanted to come back to these again was because, as Andrew pointed out in the slides, this is actually from our Ansible collection samples repo. So this is publicly accessible. I'll put a link to this in the chat, but this has links to pretty much how to do anything on zOS with Ansible. So we've got a bunch of Kick stuff. We have some stuff for even zOS Connect, provisioning, IMS provisioning, running your own zosmf workflows, doing everything you can possibly think of with jobs, data sets, even running TSO commands or running break scripts. So huge variety of stuff you can be doing. Yeah, flicking back here to just show this demo. So what we do have now is this capability to create single SMSS regions on a zOS managed node, using dataset modules for datasets, for lifecycling them independently. So you can run these either as one big playbook, or you can run them all in isolation like we did right at the start. We also have start kicks modules now. And we also have a deprovisioning playbook that allows you to come along, stop a kicks module, and then tidy up all those datasets you also created. So now we have this full region provisioning capability in the kicks collection. There was another thing we worked on last year. So let's go back to slides. Should unplay from the current slide, but let me skip through. Oh, wow, this is almost there. There we go. So we had this other thing we worked on called the zOS kicks operator. And this is something called a cloud broker operator collection that wraps region provisioning, which means you can then do region provisioning through a platform called Red Hat OpenShift, which is a enterprise form of Kubernetes, essentially, is the best way of thinking about it if you're not familiar with OpenShift. So this is its own other Ansible collection, like the kicks collection we have. But this one's called zOS kicks operator. It's also open source. You can go have a look at the source there. We do have a link to the GitHub there. And it's simply implemented as a bunch of playbooks and roles, which wrapper functionality to provision modules. So in theory, you could run them simply as an Ansible playbook. Currently, we only support running this as a cloud broker operator against WASI sandbox environments, which are emulated zOS environments. Yeah, there's a couple of other operator collections, notably one for IMS as well, to manage instances of IMS. I think it's TMDBs. I'm not an IMS person, so you have to forgive me for that. So yeah, cloud broker. Cloud broker comes with a nice UI and is basically focused around empowering developers to do self-service provisioning through an OpenShift and through a cloud-based UI. So if your developers more familiar with distributed platforms and not with zOS platforms, this kind of lowers the barrier of entry, where you can have a sysprod come up, set up your connections to your zOS machines, set up where your ZOAU instances is, set up where your Python location is on zOS Unix, and a developer can simply come along and just create a new instance of the kicks region against an emulated environment that they can then use. So I've mentioned Cloud Broker. Cloud Broker is the product that wrappers this collection and manages it as an OpenShift, within OpenShift. So Cloud Broker itself is simply an OpenShift operator, and it allows you to manage a variety of different zOS resources directly from OpenShift by creating different what are called sub-operators, which are then, so you have an operator which is lifecycled by OpenShift, and then you have a sub-operator which is lifecycled by Cloud Broker. A little bit confusing, but it's a type of operator pattern that the Cloud Broker product chose to use. So yeah, the zOS kicks operator allows you to dynamically provision and deprovision regions via an OpenShift interface directly onto a WASI sandbox environment, and in the future onto arbitrary zOS environments as well. So that'd be any zOS machine you want. It currently just wrappers a bunch of Ansible roles and playbooks, and that's how it's implemented. And then when it creates an instance, that's a OpenShift custom resource. There's a catalog of different operators that you can install. So there's the IMS one as well as the kicks one. There's another one called zOS Package Manager that allows you to install Go, Python, I think ZOAU as well. directly onto zOS Unix and set that all up for you. So I'm just going to grab a video. Fortunately, we don't have a live OpenShift environment to show you how this works, but I do have a video of one, so you have to bear with me a bit. So through this video, we'll go through, we already have this CICS TS operator installed, so this would have been done through the Cloud Broker UI. So we can go through and we can create a new CICS region. In this, we're just going to enter a name for this instance of the CICS region. We also have this nice little select zOS endpoint. So this would have been pre-set up for us through the Cloud Broker UI at this point. So if you think of this as the developer persona through this video, and we would have already had a sysadmin come along, set up a zOS endpoint, which points to a zOS machine, the same way our inventories were previously pointing to one. And that would also be set up with credentials so that this person can provision a region under those credentials. We also have this unique SysID, which is just a 3-character name that we put onto the end of zCICS to create a Apple ID on the YC Sandbox environment. Let's go through, submit 3 small fields. That will create a new instance of this custom resource. You should see this at some point. Go to status pending. There you go, running. So come along, we'll look inside, and inside here, we'll run through a bunch of tasks to work out what state our current zOS system looks like. Like, does the region exist already? Or are we creating a new one? Check that the custom resource is valid, check the Kubernetes variables all correctly set up, and make sure that we're set up against the right environment of right version of YC Sandbox, as we support a couple of different ones. It's worth pointing out YC Sandbox is a emulated zOS environment that comes pre-set up with ZOAU, Python, and a bunch of other tools like a CICS installation and an IMS installation as well. So it's quite a big sandbox environment that allows you to pretty much do anything, but it's also a emulated zOS environment. So it's not as performant as a normal zOS environment, I should say. So this demo does take a little bit of time. We'll skip ahead, have another look at these tasks. So after we've run for a little bit longer, you would see all these tasks coming through of what this operator collection is doing. And you might see some familiar things here where we come along, submitting some JCL, creating and initializing global catalogs. So same type of stuff we're doing in the other Ansible modules. And this one's just running through those Ansible tasks in the exact same way, where every single one of these tasks is simply just another task in the playbook. Come along. I'm going to skip it ahead because it does some more DefDS stuff and sets up temporary file systems. Then it goes on to creating started tasks and submitting them. And should get ahead. And we should see. Eventually, it succeeds. So if you go into FedC70, log into that YC Sandbox environment. And then if we use the SysID on the end of zCICS, so zCICS SF1, should be able to log in, and we have a CICS environment. So as simple as that, 3 input fields, and we have a new CICS region fully provisioned on a emulated environment. I go back to the slides. Cool, yeah, so Cloud Broker catalog, and yeah, that's it from us. Hopefully, we've shown you a fair few different ways of being able to run Ansible automation against zOS and automate all sorts of actions with CICS, such as provisioning different regions and managing those regions again once they are provisioned with CMCR. So thank you for listening. There's the feedback, and feel free to ask any questions.
Thank you, Andrew and Andrew, and a nice, pleasant surprise of finishing early. That's always good. And well done for fixing the demo mid-presentation. What I'll do is there's no questions I can see in the chat. I'm just going to allow people to unmute themselves in case there's any burning questions. Just bear with me a second. Okay, so everybody should have the ability to unmute themselves. So I'll just pause for 10 seconds or so in case there's any questions. Just unmute yourselves. Okay, I'll take it that there's no questions. So thank you again to the two Andrews for that presentation. Thank you everybody for joining. As you can see on the screen, we really value feedback in all the sessions. Perhaps the easiest way to provide feedback is to go to the Bring Your Own Agenda message, the Bring Your Own Agenda page on the website, and you can get a direct link to the feedback page for this session. The GSE will continue after lunch. We have 2 CICS sessions this afternoon. The first is at 3 p.m. Title is The 7 Deadly Sins of CICS Integration. That'll be presented by Scott Broad from Broadcom. And at 4:30 we have Andrew Smithson from IBM, who's the zOS Connect lead architect. He'll be presenting on bringing REST APIs to your CICS applications. So essentially how to invoke REST APIs from your CICS applications. So hope to see everybody for both of those sessions. But in the meantime, enjoy your lunch, and I'll hopefully see you later. I'll close the session now. Thank you.
Brilliant. Thanks, Steve. Thanks, everybody.
Thank you.